Okie dokie, okie dokie, artichoke. We are recording today. Let us go to the notes. Again, let me just verify. I am recording. All right, cool. So, hello, everybody. Today's notes, we are going to jump into day 2, the second day of differentiation rules. And it's not really so much rules, it's just types of problems that you may run into when dealing with just taking like the basic derivative. So, the lesson before we learned about taking the product rule and the quotient rule and the power rule and all those different rules. Today we're going to apply a few of them and just see different questions that can kind of come up. So let's get this first one. I like this problem. This is a common multiple choice question on your final exam. So let's see if we can get it. All right. It says determine the function. All right. So determine the function, which is f of x, and the value x equals a that is being derived. Then determine the value of the derivative. So then it wants us to find f prime of a. So we got to find a lot of stuff in this problem. Okay. All right. Well, hopefully when you're looking at this, you notice that we are given here in the first one. We're given the definition of a derivative. Okay, the definition of a derivative. I want you just to remember what the definition of a derivative is. And this is how the definition of a derivative pops up in multiple choice a lot. Remember that it's f of x plus h minus f of x all over h. Okay? Now, what's going on in this particular example here is that they are using this formula. Okay? But they're evaluating this formula at a specific x value, okay? At a specific x value. So they're actually already plugging in the x value that they're deriving in this formula, okay? So f of this and f of that. So from this first part here, you should be able to identify what function it is that you are taking the derivative of, okay? And you're able to do this without actually going through and figuring out the whole formula. So let's start by identifying f of x. Okay. If you can see, you see that plus h right here, that's 16 plus h. Okay, that is my x plus h. That's what I want you to recognize. That's what's being plugged into a function. So what is the function it's being plugged into? Look at the outside part. It's the fourth root of x. Okay. Now, what is the x value that they're plugging in? Well, the a value or whatever, the value that we're evaluating here, taking the derivative at, you can see is that 16. So x equals 16. And another way that verifies that is if you look right here, the 2, you see how it's minus f of x? All right. Well, this is minus the fourth root of 16. That's what f of x means. In this case, we're plugging in f of 16, which is 2. So there it verifies it. Okay. So we got f of x, we got the point at which it's being derived, and now we can actually figure out what f prime of a is, or f prime of 16. Okay. Now, in order to do this, you don't actually have to go through and actually solve out this bad boy, because we know how to take the derivative. We know how to take the derivative of this using our product rule, or I'm sorry, our power rule. So let's do that. So the derivative is going to be equal to the derivative of, I'm going to rewrite it as x to the 1/4 power, okay? Which in this case is going to be 1/4 x, and if I subtract a power from that, that's going to be negative 3/4. Okay? So I got my derivative function. It's not asking for that, it's asking for the derivative at 16. Okay? So I got the point I'm evaluating at, I got the equation, and I found the derivative. Now, when I plug that in, it's 1/4 16 to the negative 3/4 power. And I think you can simplify that down a little bit. This is equal to, scroll a little bit, this is equal to 1/4 16 to the 3/4 power. Scroll a little bit more. Now, Just the FYI. So if I'm doing 16 to the 3/4 power, that's taking the fourth root and then cubing it. The fourth root of 16 is 2. 2 cubed is 8. So I got 1 over 4 times 8, or 1 over 32 is my final answer. Okay. So that was being able to take the definition of a derivative and identify the function, the point we're evaluating, and then doing just our shortcut rules to actually compute it. Okay, so if I were to actually do the entire formula here, I would have gotten the same answer as below. And it's the same thing for the other one. Notice how it's the limit as x is approaching a. That's my other derivative formula. The limit as x is approaching a of f of x minus f of a over x minus a. I like to identify this one a little bit more because it's a little bit easier to see. Like for instance, x minus a. A in this case, and it even explicitly tells you right here, a is equal to 1. That's the value that we're trying to figure out. We're trying to figure out the derivative at a, or x equals 1. Okay. All right, now remember it's f of x minus f of a. Well, here is f of x subtract f of a. Do we see that? Like f of x in this case is x to the fourth plus x. And f of a, or f of 1 in this case, is 1 to the fourth plus 1, which is indeed 2. Okay, so we got that. All right, so we identified the point that we're trying to take the derivative of, and we identified the original function. So just doing our shortcut rules, the derivative of that is 4x cubed plus 1, doing a couple power rules. So now if I want to know the derivative and actually compute f prime of a, or f prime of 1, that's going to be 4 times 1 cubed plus 1, which is 5. All right. So hopefully that makes a little bit of sense. And yeah, we can talk more about that in detail later. But there you go. That's one type of problem dealing with the definition of a derivative and just using your shortcut rules to figure it out. All right. What's my time at right now? That's 7 minutes. Okay. Okie dokie. Well, so this next slide, this was actually a old weekly assignment that I had students do during class, practicing stuff we've already learned with limits and continuity. So if you want to try this on your own for extra practice, you can. I'm not going to go through it because we don't have time to do these types of problems, but the extra practice is there if you would like it. And we can discuss it any if you want it all. Okay? But anyway, let's get back to the lesson. All right. The next thing I want to talk about is the normal line. The normal line is another question that pops up. The normal line is perpendicular to the tangent line of a curve at P. Now, I want you to think back, way back whenever you learned about perpendicular and what that means. Let me kind of give you a little visual here. Let's say we have this graph right here. Okay, whatever. And we're at the point, say, A right here, and F of A is like right here. Okay, let's say we're looking at that point. Now, we know what the point, we know what a tangent line is. It intersects at one point. Okay, that's a terrible drawing, but there it is, intersecting at one point. Now, we do a lot with tangent line. We don't do so much with a normal line, but I've seen it come up. A normal line is perpendicular to the tangent line. So remember, perpendicular makes a 90-degree angle with the other line. All right. Now, it's still intersecting the graph at the same point, and it's still intersecting at one point most of the time. But we got to know how to write the equation of that. Okay, it's still the equation of the lines, but if you know the tangent line, you can figure out the perpendicular normal line. Because I want you to remember how this works. The slope of the perpendicular line is equal to the opposite slash I don't know if I'm spelling this right, reciprocal, whatever, the opposite slash reciprocal of the tangent slope. So we'll do a quick example on this. It doesn't pop up enough to spend a whole day on, but let's just see if we can do it. All right. All right. Here it says find the equation of the tangent and normal lines to the curve at the given x value. So it wants us to come up with a tangent line, and we know that tangent line is y minus y1 equals m times x minus x1. The only difference between the tangent line and the normal line is the slope. Still, it's intersecting at the same point. So let's start off by finding that point. The point is the easiest part since they both share the same point. The point is given to be 1, and the y value is just going to come from plugging it in here. That's going to be 2 over 2, which equals 1. Okay, so there's my point. Now, in order to come up with the derivative at this point, or the instantaneous rate of change, we need to figure out the derivative, right? So this will be good practice from our rules yesterday. The derivative, dy over dx, or y prime, whatever you want to call it. Let's do the quotient rule. Okay, so we're going to do low d high minus high d low, which is just 1. All over low low, or x plus 1 squared. So that is my derivative. And we can simplify it down a little bit if you want, especially since we're going to be plugging a point into it. So I can distribute the 2, and I can make it look a little bit nicer. So 2x plus 2 minus 2x over x plus 1 squared, which actually reduces down to 2 over x plus 1 squared. So this is my y prime. Okay. Now, that's good and all, but it wants to know what the derivative is in the tangent line at x equals 1. So what we're going to do is we're going to plug in y prime of 1, which is equal to 2 over 1 plus 1 squared, or simply 1/2. Okay. So remember, the derivative tells us the slope of the tangent line. So we have our tangent line equation right now. All right, so the tangent line is equal to y minus y, or y minus 1, equals 1/2 x minus 1. And that's a question I'm going to ask all the time, is to find the tangent line. But the normal line is just one additional step. That's why it's not really that big a deal. All you have to do is take the negative reciprocal of the slope. So this is going to be y minus 1 equals the negative, so you're going to change the sign to negative. And reciprocal means flip, so it's going to be negative 2 over 1 x minus 1. And you can just write that as negative 2 if you want, but either way, there's your two answers. Okay, so normal line. Nothing too awfully crazy or terrible about that. All right. Another common problem I see coming up. So this is an example of where basically all they're doing is testing your skills on your derivative rules. Like, that's all it is. You're not actually like computing like an equation or something like that. You're just basically rewriting your derivative rules. So let's read this first one. This is saying the derivative. Let me explain how this is read right here. This is the derivative of f of x times g of x at 3. So this is two equations being multiplied together. So we know how that derivative is going to work. Let's write it out. It's the derivative of the first, so f prime of 3, keep the second the same, plus keep the first the same, times the derivative of the second, so g prime of 3. So that's just basically remembering the rule. And then we have all those values given above, just plug them in. So that's negative 6, g of 3 is 4, f of 3 is 2, and g prime of 3 is negative 1/2. All right, what's that? Let's see. That's negative 2 plus 3 halves. Oh wait, I'm an idiot. I was adding and subtracting. It's multiplying. I'm sorry. That's negative 24 plus negative 1 or minus 1. I'm sorry. So that's negative 25. What was I doing? All right. And B is the same way. B is just saying, hey, we're going to take f of 3 divided by g of 3. We're going to take the derivative of that. So f prime of 3 divided by g prime of 3. And we know what that rule is, right? That's low, so g of 3, d high, so f prime of 3, minus high, which is f of 3, d low, g prime of 3, all over low low, or g of 3 squared. Okay, let's plug everything in. So g of 3 is 4. F prime of 3 is negative 6. Minus f of 3 is 2. G prime of 3 is negative 1 half. So we got that. All over g of 3 squared. So g of 3 is 4. 4 squared is 16. Okay. And just simplifying it, that's negative 24 now plus 1, so that's going to be negative 23 over 16. Now, I'll let you try C on your own for sake of time, because it's the same exact thing as B, but now G's on top. So it's just literally the reverse. So they want to take the derivative, and they want you to evaluate at 3. If I ever draw a line like that, just for future references, that means that you evaluate a derivative at a specific x value 3. And I can explain that again later, but try C on your own. And yeah, we can do D. D and C are pretty much the same thing, but I guess D would be worth mentioning how to do, so let's do that one. Again, derivative, we're going to evaluate it at x equals 3. We're going to do low D high minus high D low, all that stuff. Okay, so low, g of x, D high, which is the derivative of the high part. The derivative of 1 is 0, and the derivative of f of x is f prime of x. So that derivative is still the same. So low D high minus high, I'm sorry. Oh, dadgummit. I said one thing and wrote something else. I'm sorry. Low would be 1 plus f of x, D high, or g prime of x, minus high, which is g of x, and D low is f prime of x, all over low low. So all over 1 plus f of x squared. All right. So let's plug it all in. Okay. And I'll kind of resort back to the top a little bit here so we can see it. So that's going to be, oops. So it's going to be 1 plus, and I wrote x, I should have wrote 3 and all there, but 1 plus f of 3 is 1 plus 2. G prime of 3 is negative 1 half. Minus, and then g of 3 is 4. And then f prime of x is negative 6. All over 1 plus 2 squared. Okay. Just simplifying that out a little bit. That on top, that's going to be negative 3 halves minus negative 24, so plus 24 over 9, which gives me, we can keep going if you really want. I think that's going to be 45 over 2 divided by 9, if you simplify that fraction. And that reduces down to 5 halves. Okay. All right. Well, I feel pretty good about those problems. Again, try C if you want. We can finish that in class, but I kind of want to move on with it. I got two more problems. All right, and I've talked about this one already a little bit, but just something to keep in mind. Horizontal tangent line occurs when the derivative is 0, right? Hopefully that makes sense. I mean, think about this as your curve. A horizontal tangent line, so that would be right here and right here, occurs when the derivative is equal to 0, right? I mean, that's when f prime of x equals 0 because the slope of that line is 0. Horizontal lines have a derivative or a slope of 0. So I think that logically makes sense. Now, there's questions like this pop up all the time. Find all the points on this curve where the tangent line is horizontal. That's just a fancy way of saying, hey, where is all of my derivative equal to 0? Well, that's not too bad. Let's solve this out. We're going to do y prime first and get that that's 4x cubed minus 12x, and then that's it. Okay. And I'm solving for where this is equal to 0 to figure out where my tangent line is horizontal. And we're going to learn later on that horizontal tangent lines happen primarily at maxes and mins. So we're also identifying the points at which we have maxes and mins, which is pretty cool. Okay, so set it equal to 0. This just goes back to math 3 or 2, whatever. We can solve this. So take out a GCF of 4x. We're left with x squared minus 3 equals 0. And set each factor equal to 0. So we get that x equals 0, and we get that x equals plus or minus the square root of 3. So it looks like that there are 3 points on this graph where we have a horizontal tangent line. And we'll actually figure out what those points are. Notice the wording. It's not asking for the x value, it's asking for points. So we're going to figure out what all of these points are. And how do I figure those points out? Well, plug them back into your original problem. That'll tell me the coordinate points of where my tangent line is horizontal. Don't plug it into the derivative, you're just going to get 0. Okay? All right, plug 0 into the first one, you get 4. If you plug 0 in, or if you plug positive square root of 3 or negative square root of 3, because you're squaring and raising it to the 4th power, so the plus or minus doesn't matter. So you're going to get the same answer for plus or minus negative, plus or minus square root of 3. So if I plug that in, that is going to be plus or minus square root of 3 to the 4th minus 6 times plus or minus square root of 3 to the 2nd. And again, you can only, if that was like any odd powers, you would have to do them separately, but because they're both even, it doesn't matter. Let's see here. So this is the same thing as doing 3 to the, let me scroll down a little bit. I'm trying to fit it all in here. Hopefully it's not being taken up by my picture. But anyway, it's going to be 3 to the 4/2 power because we're taking the square root and squaring it. And that's going to be minus 6 times 3 plus 4. So, again, another way of saying this, 3 to the 4/2 power is the same thing as 3 squared, so that's 9 minus 18 plus 4, which gives us negative 5. So there's the 3 points at which my graph has a horizontal tangent line. So not too bad of a concept, I don't think. Set the derivative equal to 0, find the points, and then just plug them back in to find the y values of those points. Okay. So those 3 points are either maxes or mins, I'm assuming. If you were to graph x to the 4th minus 6x squared in your graphing calculator, I'm sure that would be the case. And let's see, how much time am I at? I'm at 24 minutes. Find all x values that the tangent line parallel to y equals 20x plus 3. Okay, again, I may leave this one for class just for the sake of time, but I'll get you started. I want to know all the values where the tangent line is parallel to this line. All right, what that means is, all right, so let's say that this is a cubic, so it looks something like this. Okay, some whatever. Now 20x plus 3, that is a very steep slope. It's somewhere over here. I'll draw that in red. It's somewhere like over here. I don't know. It wants to know all the tangent lines on the graph that are parallel to that tangent line. It looks like there might be 2 of them. Okay. So how we figure that out, parallel means that they share the same slope. So the slope of this line happens to be 20. So all it's asking me to do is figure out all the x values on the derivative where it's equal to 20. So this is what we're solving. And you can try to do that on your own, and we'll just do it as a class later. Okay. There's some problems in the homework. You can practice those. Make sure you have your textbook. And that's about all I got. So good job, guys. And I finished with 26 minutes. I'm doing all right.